We are still going to be working on function notation. The function notation that we did yesterday was with equations. The function notation that we did yesterday, most of it should have been a review of Algebra 1. Maybe, I'm not sure whether y'all used expressions to substitute into equations. I'm not sure if you did that in Algebra 1. Today, our topic is composites of functions. Probably something you did not do in Algebra 1. But before we can do composite of functions, we have to understand function notation, and we have to understand a little bit about what a function is. There are actually 3 ways to express a function. We can express a function, represent a function with a graph, or a table, or an equation. There's actually 4, because you can express it with a graph, a table, an equation, or you can write out in words what's happening with our function, but we don't usually do that in math because we don't like words. Okay, so we have a graph, we have a table. I didn't write down the equation. I wanted to know if you remembered. How do you take a graph or a table and come up with the equation? Do you remember how to do that? Where would I start? Well, what kind of graph is it? You see a linear graph here? So if it's a linear graph, I'm going to need a linear equation. When you hear linear equation, does y equals mx plus b come to your mind? Do you remember how to find what does the m stand for? Slope. Do you remember how to find the slope? 2 points, and then what do you do with your 2 points? Anybody remember rise over run? Okay, and so we have 2 points. Here's a point and here's a point. Rise over run. So what that would, by the way, this isn't on your paper yet. This is before we get there. So how do you find rise over run? What's the rise over run here? How far, can you tell people on the front row, how far did I rise up? And how far did I go over? Do you know what else I need there? I'm getting there, but before that, this line is what kind of line? Isn't it going down? So it needs a negative slope. Do you remember that part? Okay, what's the y-intercept here? And so in function notation, the equation would be negative 1/2 x plus 1. So we have our graph, we have our table, we have our equation. 3 different ways we can write the function. Well, if we have 3 different ways we write the function, we also have 3 different ways we could write or use the function notation. Yesterday on your blue paper, we had equations, right? And you were substituting your numbers into the equation. Do you remember yesterday? That's what we were doing on the blue paper. Today, we are going to look at function notation from tables and also from graphs. And so, since we have 3 ways to represent a function, we have 3 ways to use our function notation. Now, once again, this is before problem number 1. These problems are not written on your paper, but before we can do compositions or composites, we just have to understand how to use the function notation with tables. You see these tables on your, are these the same tables that you have on your gold paper there? So, what does G of 4 mean? Do you remember what the G is? My first period didn't remember, or they didn't know how to say it. The G is the name of the function. The G is telling me which table to use. If this says G, which table am I going to use? The red one or the black one? Why? Why am I going to use the red one? Because right up there it says G. So that tells me to use the first table because this table is labeled G. Now, this is where the X usually goes. This is telling me that in the G table, the X value is 4. Put your pencil on that in your table. On the G table, put your pencil on the X value of 4. What's the Y value that goes with it? This is the G table telling me to use this table. This is the X value of 4 in the table, and the Y value of -3 goes with it. That's how the function notation goes with the table. So what does this mean? It means that I am going to use the G table. I am going to find -1 in the X column, -1 in the X column, what goes with it? See how that works? This tells me the function name is f. Again, these problems aren't on your paper. Just look up here with me, please. But the tables are on your paper. This tells me f, so I'm using the red table or the black table. This one is table F. In the F table, in the X column, I find +3. What's the Y value that goes with it? In the table labeled F, I find an X value of -1. What's the Y value that goes with it? What? In the table labeled F, I find the X number of 4. What's the Y value that goes with it? Is there a problem here? Is there a 4 in this table? So what does that mean? No solution, or there's not a number that goes with it. Okay, we got that much? Can you do that much? So then we are ready to do problem number 1. What does all of this strange looking stuff mean? Well, this is a composite. And to confuse things even more, there's 2 different ways that you will see composites written in books and mathematical literature. Both of these mean the same thing. They mean I'm going to take the answer to one function and put it in the other function. When you have a composite where you're given the number, you start from the inside and work outward. Maybe we should write that on your paper someplace. Write on your paper someplace, inside first. What do I mean inside? This is what I'm calling the inside. We're going to start on the inside. We're going, and see where you have problem number 1? Write this underneath problem number 1. There should be a little space there. That's what we're going to do first. G of -3. So G tells me which table to use. First table or second table? First table. -3 tells me where to go in that table. If X is -3, what's the Y? The answer to this part is 2. So then I put the 2 in the outside function. What's f of 2? This tells me to look at the table called f. That would be the second table. Find 2. What's going to go with it? This is the x value. What's the y value? The answer to the composite is -1. So what a composite is you're taking the answer to the first function and using it to complete the second function. And how do we do it? Inside part first, or inside out. Okay. We got all this funny looking stuff. We can both of these mean the same thing. Both of these mean I start here. G of negative 1. I look at the table called G and I find negative 1. If the x value is negative 1, what's the y value that goes with it? Then I take that y value and I put it in the outside function, the f function. So I look at this table. In this table, if x is negative 1, what's y? Hopefully it's not too hard to do this with tables. So, Eli, can you tell me, this is where we're going to start on problem number 3, can you tell me what G of 0 is equal to? He's looking right here on the chart. Victoria, can you tell me what to do next? What am I going to do with the 3? Yeah, right there. That's where she was pointing. Okay, now what? So she looks right here on this table, and the final answer is 2. Eduardo, do I have the right name? Okay, and so can you tell me what G of 4 is equal to? And so then I'm going to take that negative 3, and that answer goes into the next function. Sarah, can you tell me what f of negative 3 is equal to? That is the final answer. William, can you tell me where to start? What's negative 5? G of 1 is negative 5, he said. Is he correct? Okay, that's where I start. Now, Caitlin, what do I do next? And then, why? Now, there's one more. Oh, wait, no, never mind. We have a problem number 6. I was a step ahead of myself. Anderson, what is G of negative 4? It's not on the table, so what is that? What do you do? If I don't have an answer here, can I have an answer there? So the answer is none or no solution. Now, wait, no, don't turn the page. There's one more example that I should have put on the first page that I need you to add to the first page. So, on the bottom of the first page under problem number 6, we can't really call it number 7 because number 7's on the next page, I believe. So, we need to do this problem also. Because I don't want you to think that you always have to start with the G of x. Because what's in the middle this time? What am I going to start with this time? You start with whatever's in the middle. If the f function is on the inside, then you start with the f function. Alejandro, where did I put you? Oh, okay. And so, what's f of negative 1? It is equal to 0. Now, I didn't put as many blanks here. And so, Michael, what am I going to do next? I don't have the parentheses there, so I'm going to have to write it for myself. So what am I going to write next? What am I going to do with that 0? Sorry, that's an ugly looking G, and I just made it look worse. So, now I'm going to put it on G. So what's G of 0 equal to? And so the final answer is 3. So whatever this is on the inside, that's what you start with. You don't always start with g of x or g of something first. Now, before we go on to those other problems, I want to give you a minute to work at least, did I say only? At least problems 1 and 2. Because we got to get this in our brain before we add more stuff in there. Okay, do I have somebody here today that was absent yesterday? Okay, so did you get your worksheet out of the crate? There's a couple of them I want to look at with you. Why is 4 different? Oh, wait. Let me go here. And so 1 and 2 should look like this. This is your final answer. This is the only thing I should see in the blank. You don't have to write this step down. It's usually a good idea to write that one down. You can write this one down as a separate step, or you can just put the answer there. But this is where the final answer goes. Now, 4 looks different. But it means the same thing. You still work inside out. What's g of 6? 2. And so you figure out h of 2. And what's h of 2? And so 1 is your final answer. So it's, I don't know why there's 2 separate notations that both mean the same thing. Okay, the next one I need to look at with you is problem number 7. Please look at problem number 7. It's getting uglier looking. What am I going to do first on problem number 7? What is h of 4? So what am I going to do with the 3? I'm going to still keep working inside out. So I'm going to do the g function next. So what's g of 3 equal to? And then I'm going to take the 1 and put it in the function called f. And what's the final answer going to be? And so that is back to the final answer. Okay, now I need you to set that aside, and we need to go on for the rest of the notes. So please look at the rest of the notes. So there are 3 ways to represent a function. On the blue homework paper, we did equations. On the first page here, we did tables, and now we're going to look at graphs. So, this f out in front is the name of the function. So I'm going to use the first graph or the second graph. This tells me that the first graph is named f. This is the x value, and I'm going to find the y value. If on this graph the x value is 0, you go to the 0 on the x-axis, and then you either go up or down to hit the graph. This point right here on the graph is 0, -3. So if the x value is 0, what's the y value? Problem number 8. The graph is called f. That means I'm using this graph. If the x value is -5, what's the y value that goes with it? So I have to go over here. 1, 2, 3, 4, -5. This point right here is -5, 1. Go to the -5 and then just go up or down to find the point on the graph. If x is -5, the y value is 1. Little bit harder from the graph. On problem number 9, which graph am I using? Graph called G. I go from here, I go to -1. This point right here on the graph is -1, 2. So on the graph called G, if the x is -1, what's the y value? This is an x value of +2. This point right here is 2 and 4. On the graph called G, if the x value is 2, what's the y value? You see how I'm finding the points on the graph? If you wanted to, you could take the graph and make it into a table if you wanted to do the extra work. Okay, now how do I do a composite then if I have a graph? Well, I still start inside out. On the graph called G, if the x value is 0, what's the y value? Then I take that answer and put it into the function called f. On the graph called f, if the x value is 4, what's the y value? And that's the final answer. See if you can do this one. Alex, where am I going to start? G of -2 is how I say that. So where do I go? First graph or second graph? Second graph, then what do I do? And so that goes, -2 goes with 1. Okay, keep going. Now what? And that 3 is the final answer. Questions? Aha, would it be -3? Why is it -3? It went down, so this should have been a -3. He probably had that on his paper. Now, this is that other notation. Sometimes, hopefully for obvious reasons, this is called the fog notation. And so this is where you start. G of 0. So I'm going to start on this graph. X is 0, 1, 2, 3, 4. Y is 4. Then what? I take the 4 and put it in the outside letter. F of 4, 1, 2, 3, 4. And this point right here is 4 and 1. If this is 4, this is equal to 1. 1 is your final answer. G of -4 is where we're going to start. On problem number 14, G of -4. 1, 2, 3, 4, 1, 2, 3, 4. This point right here, G of -4 is equal to +4. I take the +4 and put it in the function called f. 1, 2, 3, 4, and that matches up with 1. Try this one. Okay, so do we have the correct answer on problem number 15? Now, we're going to come back to problem number 16 tomorrow. We're going to stop right there for now.